Today I will present regarding navigating mobile UI with large blank models. So we do interact with devices using natural languages a lot in these days. You may have used the Hey Siri or OK Google, and we presented LangAware previous week. Uh, Even though I will not upload a related video in my personal account. However, there is a paper named LangAware, which uh, about utilizing the sensor data to more specify the user utterance uh, to get more specified results from as an LLM inference. So if you are interested, you can refer to the uh, below source reference. Anyway, so language allow us for efficient communication, particularly when we have like disablement or impaired modality, or we are situationally impaired. Situationally impaired means like when we are running or when we are doing some task with our hands, being busy, then we cannot use our hands. That means that is situationally impaired. Hand is being situationally impaired. Such things. Or we are looking at something, we have to looking at something and want to interact with our natural language, then our vision is situationally impaired. Yeah. So when we want to control the GUI using our natural language speech, then how can we do it? Yeah. So for example, when we try to utilize the GUI context, for example, when we are washing the dishes, our hands are situationally impaired, and we may want to fast forward the 30 seconds, which will be about the advertisement. Then, in that case, we may want the agent to fast forward instead of us uh, by some controlling the GUI. So there are like three aspects or three actions to consider regarding those interactions. So first one, how are we going the AI agent be understanding the mobile GUI? So how will give the mobile GUI as an input to the AI, and what kind of interactions are available, and how can we determine the quality of the interaction? So I represent two papers addressing the problem. First one is published in Kai 23. It is actually by doing the job, converting screen into text. And the second paper utilized the GPT-4 vision, which is not LLM, but LMM, multimodal model. So it actually inferred directly from the screen image. I'll pass this. And let's move on to the first paper. So a bit context for the paper. The paper is published in 23, in Kai 23. However, like it must have been studied around 22. So at that time, there was previous papers approached the problem by training specific data set for each task they are trying to solve. And also editing performance at the time was not that good. At the time there was GPT-3, and the authors utilized the PaLM model, and the input token limitation was 1920, so they could not use much more than two examples as an initial learning. So they utilized two-shot learning at most, and obviously LMM is not available at the time. So how did they give an input of more GUI to LLM? So LLM only interprets the text, so they need to somehow represent the screen into text format. They utilize the Android view hierarchy, which is text information you can get from the Android app, or and also the Rico data set they use to evaluate this whole stuff. Some of the tasks. they provided the Android view hierarchy. So they take the approach of converting the Android view hierarchy into HTML formatted input. Yeah, so to represent the view hierarchy as HTML, first of all, they chose the HTML because it was popular, and they thought that POM must have used lots of HTML data as training data. And so to represent the view hierarchy, they map the Android classes into some kind of HTML tags, and they put the resource name contents, which is from the view hierarchy, between the tags, as like normal HTML content will do. And they add numeric ID indices for references to specify which UI element they are talking about. And there are two prompting techniques the authors utilize. First one is Ansha learning, and second one is chain of thought. And the Ansha learning means simply when it is three-shot learning, that it means that you provide three examples during the prompt to facilitate the inference process of the LLM. So, and can be uh, and can be replaced by the number of examples you provide. And the chain of thought is about like explicitly uh, inferring the intermediate result during the prompt during the inference process. So in the prompting session, in the prompting contents, you provide how they need to infer the intermediate results during the inference process. So on the right box, red box, they provided the intermediate results they want to see from the model output. And as you can see on the below, the green box, the green highlighted text show that LLM also followed the logical intermediate steps that they were designated. And it is known that chain of thought approach actually increases the performance by applying that method. You can refer the source in the below. And the authors also apply those two prompting techniques. On the left side, there is chain of thoughts, how they apply the chain of thought for their own problems. And on the right side, there is Ansha learning example, and they use 0, 1, or 2 examples for their experiments. And they divided the available interaction types into 4 types. And they suggested 2 axes of conversation. First one is who initiated the conversation, and second one is the type of the speech. So for the type of the speech, they divided that into soliciting and providing. Soliciting is basically asking stuff, and providing is like giving the information, such as when user initiated, and giving the information, provide the information to agent. That must be command. The command can be one sample of that task type, and agent providing information to the user can be brief summary of the screen. So they suggested 4 task types, and they induced the 4 simple tasks from the task types. So each of the task types are correspond to each types. Each sample tasks. So there are 4 sample tasks, and they evaluate the quality of the interaction using several benchmarks and their own metrics. So first of all, the first task can be screen Q&A, so where the question is given and agent needs to answer the question. And they figure out that the baseline here is the DSTLBERT, and the ground LLM is the POM model authors used, and they compare the result with the ground truth. And Zero Shot shows that Oh yeah, zero shot means there was no example in the case. However, for the screen Q&A, the GPT, I mean Palm model already got good scores compared to DistilBERT, which was so tight at the time. And yeah, by giving two sample, it could dramatically increase, even with the one sample, the overall quality of the results. And regarding the columns, exact matches, contains GT, etc., you can see the definitions here. And command to target UI is about how to perform the uh, exact sample cases by following the steps. And yeah, in this case, the zero-shot LLM did not perform well. However, like by giving one or two shots of informations, they showed good performance compared to SOTA at the time, Seek2Act. And in this case, Seek2Act was much better compared to the two-shot LLM. However, like they required a lot of data set specifically tailored to the task. Authors mentioned around like hundreds of thousands samples must have been used to train the Seek2Act model. However, authors just utilized the Palm model, which was pre-trained, so it was much more easier for them to uh, apply this and conduct this task using easy model, for only using the prompt examples. Here, cross-app and in-app means whether they use the specific app-specific prompt examples during the inference, as in like Angel learning examples. And screen to question, they generated questions out of screen. And here, because there was no benchmark for this task, they used a template by replacing the contents of resource tokens, which was provided from the view hierarchy. So when you read the template text sentences, it is quite awkward compared to LLM, which is quite readable, and like the content is quite reasonable. Yeah. And they also find out that compared to the template being fragmented into input field contents, however, like LLM could combine the element and ask one question that covers two input fields, stuff like that. And because there was no benchmark, they had to evaluate it with the human participants. And yeah, the grammar was the Rickert scale from 1 to 5, and LLM did very well. And relevance is got the relevance research from the human evaluator binary research, such as 0 means it was not relevant and 1 means it was relevant. And yeah, by averaging it, it was like it showed like 92% relevance, which was much better than the template. And yeah, the coverage was not 100%. However, the authors said that that covered almost all intelligible input fields related questions. Yeah. And they also summarized the contents well. The thing here is that compared to the ground truths or human labels or the SOTA results of screen to words, this screen summary using the LLM did use the context of other UI components such as fax file app screen. Yeah, here they cached the name of the app was the fax file, and also there were other functionality provided in the screen. And regarding the tasks evaluation, the blue stuff like the metrics, like scoring automated scoring metrics, Compared to that, they did not show good performance even for the two-shot LLM. However, like the author says that because it was like word-to-word match between the provided one and the ground truth, which made the screen to words got the higher score. However, when human evaluated as the right side, the LLM showed better scores from the human annotators. And interesting discussions by authors were like this. So, in the 6.1 section, implication for the natural language related applications, uh, yeah, so they said that they can give the chance to refine the instructions for end users by prompting themselves or giving some examples by themselves. And also, uh, they said that multi-turn because the whole task experiments in that paper was done in the one-turn conversation, single turn. I don't, yeah, a single shot. So the multi-turn conversation will help clarify ambiguity through iterations. Yeah. Uh, there was critique for my colleagues in my lab. Uh, yeah, I thought in that way, and there was weaknesses we discussed about, and there is second paper, and this paper utilizes the GPT-4 vision, which can interpret the images. Yeah, so they input the mobile GUI into LMM by just capturing the screen. And yeah, I will just briefly explain about this paper. Uh, so they explore the two interactions where to understand the available actions in screen and name the UI ID to execute certain required tasks. And they evaluated the quality of the interactions for iOS screen dataset and Android. And for the first one, the authors self-collected the results, the dataset. And yeah, I will show you the first two tasks related to iOS screen dataset. The first one is to interpret the screen captured image and provide related information. So the GPT-4 vision. So in this case, this is zero shot, so there was no example being given. However, the GPT-4 vision understand that the limit of the page open page is limit number is the 500. Even I didn't know that. However, like it provided that information, so you might need to close some of the existing tabs to open some more. And regarding the road closure related notifications, the GPT-4 Vision recommends you to click the 6 alerts stuff to see more information. And to execute some kind of actions, the authors provided the UI numbers, IDs, to specify which actions they can execute. And GPT-4 Vision says the answers the query well, as human will do in this like iOS update. Go to the general options, or for the more like specific benchmark or evaluation metrics, go to the leaderboard link on the right page, image figure. Yeah, from now on it was more like the ideation stuff, so I think I can skip this part. Yeah, thank you for listening.